Hello learner, I welcome in the course Introduction to Fluid Mechanics. So today I will discuss the properties of fluid, and in properties of fluid I will discuss the firstly I will discuss what is fluid mechanics, and then what is the different types of fluid, and then uh, some basic properties of the fluid like what is density, specific weight, specific gravity, and compressibility and the bulk modulus of the fluid. And then I will solve problem based on the compressibility and bulk modulus. So let us start about the introduction to fluid mechanics. So before I will start the properties of fluid in module 1, let me discuss the entire contents that I will discuss uh, in this course. So in module 1, I will discuss the basic concept and definition. So if I talk about the syllabus or content, so in module 1, uh, this distinction between the fluid and the solid, a definition of density, specific weight, specific gravity, kinematic and dynamic viscosity, variation of the viscosity with temperature, what is Newton's law of viscosity, what is vapor pressure, what is boiling point and cavitation, and surface tension, capillarity, bulk modulus of elasticity, and compressibility. So out of this, today I will discuss the basic definition like what is density, specific weight, specific gravity, and then I will also discuss what is the bulk modulus of elasticity and compressibility. In module 2, I will discuss the fluid statics. In fluid statics, I will discuss the discuss about the fluid pressure by pressure at a point by what is Pascal's law, and pressure variation with temperature, density and altitude, and what is U-tube manometer and single column manometer and inverted manometer. I will also discuss the what is the hydrostatic pressure and force, horizontal, vertical, inclined surfaces, and what is buoyancy and stability of floating bodies. In module 3, I will discuss the fluid kinematics, and in fluid kinematics, I will discuss the classification of fluid flow, like what is steady flow and unsteady flow, what is uniform and non-uniform flow, what is the difference between laminar and turbulent flow, and what is the difference between rotational and irrotational flow. And in this module, I will also discuss the very important terminology like what is velocity, potential, and stream function, and then what is the significance of the stream function in fluid mechanics. And after that, in module 4, I will discuss the fluid dynamics, and in fluid dynamics I will discuss the what is surface and body forces, and Euler's equation, Bernoulli's equation, derivation of Bernoulli's equation, and then various forms of Bernoulli's equation, and then how to compute the discharge and velocity by various apparatus like venturi meter, orifice meter, pitot tube, and after that I will discuss the what is free vortex and forced vortex, and what is the very important dimensionless parameter like Reynolds number, Proud number, Mach number, Weber number, and Euler's number. In module 5, I will discuss the laminar flow through circular pipes, and then what is Stokes law and measurement of viscosity. In module 6, I will discuss the dimensional analysis and hydraulic similitude, like what is dimensional homogeneity and what is Rayleigh method and Buckingham-Pi theorem. These things I will discuss in the module 6. In module 7, I will discuss the flow through pipes and various losses, major and minor losses, and what is Darcy-Weisbach equation, and how to compute the major losses and minor losses, and Hardy-Cross method, of course, I will discuss in module 7. And in module 8, I will discuss uh, the turbulent flow, Reynolds experiment, and what is the transition from laminar to turbulent flow, what is the condition and the definition of turbulence, and scale and intensity causes of turbulence, and what is Prandtl mixing length, and universal velocity distribution equation, and what is Moody diagram. These things I will discuss in the module 8. So before I will start the properties of fluid, I will prefer, or I will refer these references you can use. Hydraulics and Fluid Mechanics by PM Modi and SM Set, and it's the standard book house. And then we can also use fluid mechanics and machinery, and then theory and application of the fluid mechanics by K. Subramanian. And these are the various references. So let us start about the fluid mechanics. So what is mechanics? So mechanics is the study of motion, and there are two types of motion: kinematics or dynamics. So what is kinematics? So study of motion without the consideration of basic causes of motion, that is force, like velocity, acceleration, jerk. And in dynamics we will study the motion with the consideration of basic causes of motion, that is force we will consider in the dynamic. So what is the definition of fluid? So fluid is a substance which is having the ability to flow under the action of shear and tangential force. And basically there are two types of fluid: ideal fluid and real fluid. What is ideal fluid? So the fluid which has no viscosity, surface tension, and bulk modulus is infinite. So such type of fluid is called uh, ideal fluid. And the real fluid which have the viscosity and the surface tension, and the bulk modulus value is finite. So such type of fluid is called real fluid. So basic fluid property I'm going to discuss, that is you already know what is density. So density is the ratio of mass per unit volume. So here m is the mass and v is the volume. So the we can write unit is either it is written in the kg per meter cube, gram per cc, or here I have written the density of water, that is 1000 kg per meter cube. Similarly, the second basic fluid property, that is the specific weight. So there is a little bit difference between the density and specific weight. So specific weight is the ratio of weight per unit volume. Here density is mass per unit volume and weight is equal to m into g. So here we can write uh, specific weight is equal to weight per unit volume, or we can write weight is equal to m into g divided by volume. And we know that we have already discussed that mass per unit volume is the density. So we can write uh, specific weight is equal to density into multiplied by acceleration due to gravity g, and the unit is either Newton per meter cube or kilonewton per meter cube. Similarly, the another fluid property that is very important, that is specific gravity. So specific gravity is the ratio of density of fluid to the density of standard fluid. And the standard fluid, if I for a liquid, the standard fluid is water, and in air generally we take the air as a standard fluid. So specific gravity is the density of fluid by this density of standard fluid. Similarly, I am going to discuss the what is bulk modulus, bulk modulus. It is denoted by K, and compressibility. It is denoted by beta. So what is bulk modulus? So in fluid solid mechanics, bulk modulus is the ratio of normal strength ratio of normal stress to the volumetric strain. So let capital P be the original pressure, and capital V is the volume. Similarly, dP is the change in pressure, and dV is the change in volume. So the bulk modulus can be written as dP divided by minus dV by V, because change in volume, or we can write minus dP divided by dV by V. So this is the bulk modulus. If I bulk modulus can also be written in terms of density. So we know that mass is equal to density into volume, and that will be the constant. So if I differentiate, so it will be d rho into V plus V into dV into rho is equal to 0. If I write V into d rho is equal to minus dV into rho. So we can write minus dV by V is equal to d rho by rho. So bulk modulus I have written K is equal to minus dP by dV by dV. So here we can write from, let us assume this is equation number first. So put the value of minus dV by dV by V. So we can write K is equal to dP by dV by V is equal to, we can write dP by d rho by rho. So the bulk modulus can also be written in terms of change in density and change in pressure. So compressibility is the reverse of bulk modulus. Compressibility beta is equal to 1 by K. So inverse of bulk modulus is the compressibility. So this compressibility can be written in two form, that is one form is uh, adiabatic form, and so we can write the bulk modulus, isothermal bulk modulus. Two cases I will discuss: isotherm bulk modulus KT. So we know the ideal gas equation. Ideal gas equation, that is P is equal to rho R T. Here isotherm is temperature is constant. So dP by d rho is equal to R is the gas constant and T is the temperature is constant, so it will be RT. So if I put the value of dP by d rho, because bulk modulus KT can be written as dP by d rho by rho. So we can write rho into dP by d rho. So it will be rho and dP by d rho is RT. So it is rho RT. So we can write P. So isotherm bulk modulus is equal to the pressure. Isotherm bulk modulus is equal to pressure. We can write isotherm bulk modulus is equal to pressure. Similarly, the second condition, that is adiabatic bulk modulus. So we know the adiabatic equation, that is PV to the power gamma is equal to constant, where P is the pressure, V is the volume, and gamma is the adiabatic index. Adiabatic index, that is the ratio of Cp by Cv, specific heat at constant pressure divided by specific heat at constant volume. So we can write from equation this equation 1. So P into m by rho we can write to the power gamma is equal to constant. So we can write mass is constant, so we can write P is equal to C rho to the power gamma, where C is constant, because here M is constant. So P is equal to rho to the power gamma and constant divided by M. So it is also a constant, where here C is constant. So if I differentiate dP by d rho, so it will be C into gamma into rho to the power gamma minus 1. So if I put the value of dP by d rho once again in the expression of bulk modulus, so adiabatic bulk modulus Ka is equal to dP by d rho by rho. So we can write dP by d rho is rho into dP by d rho, and dP by d rho we can write rho into C into gamma into rho to the power gamma minus 1. So Ka is equal to C into gamma into rho, and here C into rho to the power gamma, sorry, here C into gamma, here C into gamma into rho to the power gamma, or here we can write P is equal to C rho to the power gamma. So we can write Ka is equal to gamma into P. So this is the expression adiabatic bulk modulus Ka is equal to adiabatic index into pressure. Gamma is the adiabatic index into pressure. So let us take the problem. The bulk modulus of water is 210 into 10 to the power 4 kilonewton per meter square. Bulk modulus K is 21 into 10 to the power 5. What pressure required to reduce the volume of water in a closed container by 2%? dV by V is given, that is 2% means 0.02. So we have the relation bulk modulus is equal to dP divided by dV by V. So here we can write dP divided by 0.02, and the bulk modulus is 21 into 10 to the power 5 is equal to change in pressure divided by 0.02. So if I write the value of dP, so it will be 21 into 10 to the power 5 into 0.02. So it will be 21 into 0.02, so it will be 0.42. 0.42 into 10 to the power 5 kilonewton per meter square. So change in pressure is 0.42. 21 into 0.02, so it will be 0.42. So we can write dP is equal to 0.42 into 10 to the power 5 into 10 to the power 3 Newton per meter square. So change in pressure is 42 into 10 to the power 6 Newton per meter square. So dP can be written as 42 mega Newton per meter square. So this is the answer. What is pressure is required to reduce? So it is 42 mega Newton per meter square. Let us take the another problem. An empirical pressure density relation for water P by PA is equal to 3001 rho by rho A to the power 7 minus 3000, where suffix A refers to the atmospheric condition. Determine the bulk modulus of elasticity and compressibility of water at 5 atmospheric pressure. And 1 atmospheric pressure is 101 into 325 kilonewton per meter square. So if I differentiate this value, so dP 1 by PA dP by d rho is equal to 3001 into 7 divided by rho A to the power 7 into rho 6 minus 0. So we can write dP by d rho is equal to dP by d rho is equal to PA into 3001 into 7 divided by rho A divided by rho A, and the expression of bulk modulus is dP divided by d rho by rho. So we can write rho dP by d rho. So dP by d rho can be written as rho into PA into 3001 into 7 divided by rho A. We have one rho A to the power 7 into rho 6 into rho. So K can be written as rho to the power 6. So PA into 3001 into 7 into rho by rho A to the power 7. And rho by rho A to the power 7 can be written as rho by rho A to the power 7 is equal to P by PA plus 3000 divided by 3001. So can be written as K is equal to PA into 3001 into 7 into P by PA plus 3000 P by PA plus 3000 divided by 3001. 3001 cancel. So we can write K is equal to P by PA plus 3000 divided by into 7, not divided by, into 7 into PA. So K can be written as K is equal to 3005 into 7 into PA. PA is given 101 into 0.325. So 101.325. So the bulk modulus is 3005 into 7 into 101.325. So it is 2.13 into 10 to the power 6 kilonewton per meter square. So the bulk modulus is this way. Similarly, compressibility can be computed as beta is equal to 1 by K. So it will be 1 by 2.13 into 10 to the power 6. So beta is equal to 1 divided by 2.13. So it is 0.469. 0.469 into 10 to the power minus 6 meter square per kilonewton is the compressibility. So the bulk modulus is 2.13 into 10 to the power 6 kilonewton per meter square, and compressibility is 0.469 into 10 to the power minus 6 meter square per kilonewton. Let us take the another problem. Calculate the percentage change in density of gas if it is compressed isothermally from 1000 atm to 1001 atm. So we know the gas equation, ideal gas equation. We know ideal gas equation, that is P is equal to rho R into T. Similarly, dP is equal to d rho R into T, because isothermal means temperature is constant. For isothermal process, temperature is constant. R is a gas constant, this is also constant. So we can write dP is equal to RT into d rho. This is equation number 1. This is equation number 2. So 2 by 1 operate 2 divided by 1. So it will be dP by P. dP by P is equal to RT into d rho divided by rho R into T. So it will be d rho by rho. So dP by P is equal to d rho by rho. So we have to find the percentage change in density of gas. So percentage change in density of gas, percentage change in density of gas, that is d rho by rho into 100, this can be written as dP by P into 100. So it will be 1001 minus, it can be written as 1001 minus 1000 divided by 1000 into 100. So the percentage change is percentage change is 1, so it will be, the value is 1 divided by 10, so 0.1%. So the percentage change in density is 0.1%. Here in the question we have to find the calculate the percentage change in density. So we have computed, we have uh, derived the relation between the change in pressure and the change in density, that is equal in isothermal process, that is dP by P is equal to d rho by rho, and then we have computed the change in the percentage change in density, that is equal to 0.1%. So in the next class I will discuss the viscosity, and then types of viscosity, and then what is Newton's law of viscosity, and then we will solve problems based on the Newton's law of viscosity. So take care of your health and happy learning.